For this example, we'll practice using the law of universal gravitation. This problem says, you weigh 710 newtons. What would you weigh if the Earth were 5 times as massive as it is and its radius were 2 times its present value? Answer in units of newtons. So to make this faster, I wrote down what we were given. I'm going to use lowercase w for weight. We know the formula is mass times the acceleration of gravity, and we know it's equal to 710 newtons. What we need to find is, based on the new conditions of the Earth, stated over here, what is the new weight? And we know we have to use the law of universal gravitation, which is here. This is the universal constant of gravitation, big G, some people call it, times the product of the mass, times the product of the masses. Normally I like to use the capital M for the bigger mass, lowercase m for the smaller mass. And then we divide by the distance squared. In this case, the interaction, the weight is a byproduct of this force between the person, whose weight is 710, and the Earth, meaning that capital M is the mass of the Earth, and lowercase m is this mass, let's say your mass, because it says you weigh, correct? So your mass. Okay. So one thing I'd like to add is the weight is equal to this. Okay, again, the reason why we feel our weight is the effect of gravity on every single one of us. So then we can say mg is equal to the law of universal gravitation. And I know we can cancel the m, but I don't want to do that now. And I just want to remind ourselves that this is equal to the weight. Okay? So what do we do about the new weight? Well, first of all, using the same formula, the new weight is going to be equal to the universal constant, because it's just a constant, times the new conditions for the Earth, which we'll call m prime. This is weight prime. This is a prime. Your mass will not change, because what's changing is the Earth, divided by r prime squared, because we are changing the mass of the Earth and the radius of the Earth. We know the relationship between them, which is to say, the new mass for the Earth is going to be 5 times the original mass, and the radius, the new radius, r prime, is going to be twice the original radius. So now what I'm going to do is plug these values in here. So we'll have weight prime is equal to the universal constant. M prime is 5m times lowercase m divided by r prime is 2r squared. Well, let's clean this up. Let's get rid of the parentheses. We don't have to do anything in the numerator. For the denominator, we'll distribute this square, and we'll get the following. Weight prime is equal to the constant times 5. That looks more like an S. Capital M times lowercase n divided by 4r squared. I'm going to move this fraction, the 5/4, in front, and you'll see why, okay? You'll see why. So then, weight prime is equal to, I'm going to move the 5/4, split it, times constant, capital M times lowercase m, divided by r squared. Notice how this is the original law of universal gravitation. And we know that this is equal to the weight. Okay? This is equal to the weight. So all we have to do is substitute or replace this with the original weight. And that's a quantity which was given to us, 710. So all we got to do is plug it in. I'm going to work on the left side now. The new weight is 5/4 times 710 newtons. Let's get decimals going. So weight prime is 887.5 newtons. That's it.